My name is Mark Frankel. I am on staff here at AAAS. I direct a program called Scientific Responsibility, Human Rights, and Law. So that means we deal with a lot of issues from the point of view of ethics, law, and human rights, and the issues that advances in science and technology raise. This is the second event under the series we call Neuroscience and Society. I'm delighted you're here. And as you can see, the title is From Birth to Two, Prepping for Life. We have an excellent group of speakers to present on that topic. Unfortunately, none of the infants we invited were able to attend. They had conflicting schedules, as I understand it, about this time. But, you know, who among us is not infatuated by babies? Like me, you've probably taken a long, hard look at an infant and said to yourself, I'd give much more than a penny for her thoughts. You know, what are they thinking? What are they seeing? And I think I expect us to gain some insight into that question tonight. And I want to tell you a little bit about how we're going to proceed. But I do want to tell you and remind you that this is a partnership, the series between AAAS and the Dana Foundation, and I want to thank and acknowledge the Dana Foundation for its support and for its help in planning the sessions that we have during the course of the year. We will post on our website more information about the next two in terms of dates and topics, but I can tell you at least this, that the one in September will be on mental health across the age spectrum, going from children, adolescents, to midlife, to the elderly. And then our final one of the season will be on genius and creativity. And I can't tell you much more than that at this point in time. We haven't been creative enough to put the program together. Since the infants are not well represented tonight, I want to speak for them by quoting from and even adding to something called the Toddler's Creed. It was authored by a child psychologist, Burton White. Anybody familiar with it? Does it resonate? Well, let me read it to you. Maybe it'll resonate as I read it. So it goes like this. If I want it, it's mine. If I give it to you and change my mind, it's mine. If I can take it away from you, it's mine. If I had it a little while ago, it's mine. If it's mine, it will never belong to anyone else, no matter what. If we're building something together, all the pieces are mine. If it looks like mine, it's mine. And here's my addition. If you think it's yours, think again, it's mine. So, having spoken for the toddlers, I do want to bring your attention to the photos here. These are not your ordinary internet photo stock pics. These are members of the AAAS family. This young man over here, his name is Tyler. He's obviously not a very happy boy at the moment. Is the grandson of one of my colleagues here, Debbie Runkle. Debbie is here. Raise your hand, Debbie. There she is, proud grandmother of Tyler. And this fellow, who is smiling, and I wish I could tell you that the reason he's smiling is because I'm standing in front of him. But that's my grandson, Max, who will be 2 years old this Sunday. So this is a wonderful session. In one sense, I wish he were here. In another sense, I'm glad he isn't. All right, now to our program for the evening. You have programs, so I'm not going to go into a lot of detail in introducing our speakers so that we can get on with the substantive issues. After each of them, after all three have spoken, I'm going to ask them to come back up, sit in those chairs over there. We'll have a little conversation. I'll moderate that, and then we'll open it up to all of you. We have mics on the sides, both aisles, and invite your questions or reactions to what they have to say. Let's see, what else? I think, one other thing. After we're through, with the program, which will be between 7 and 7:15, we'll go outside the auditorium and there'll be a reception, and you'll have an opportunity to talk again, maybe one-on-one with the speakers as they presented. They'll be joining us as well. So let's get on with our program. Our first speaker is Dr. Pat Levitt, who's the Simsman Chair in Developmental Neurogenetics at the Institute for the Developing Mind at Children's Hospital, Los Angeles, and the W.M. Keck Provost Professor of Neurogenetics at the Keck School of Medicine at the University of Southern California. Among his accomplishments, I'm most pleased to highlight, given where we are and the sponsorship of this program, that he's an elected member of the Dana Alliance for Brain Initiatives and also an elected fellow of AAAS. So he will set the stage for the evening program by discussing some of the factors that influence postnatal infant development, including the interaction of genetics and the environment. So please join me in welcoming Dr. Levitt.
Thank you. Again. Can you hear me? That's good? I'm not making a phone call, I'm just setting my timer. It's 6 o'clock, we're not going to end at 7, I'm just pointing that out. Okay, so I got to do this. Sorry about that. And here we go. I took a video. Can somebody's going to switch that computer? I took a video of the rain. I live in Los Angeles, and I literally have forgotten what it actually looks like. But the taxi driver who drove me 3 blocks over here from the hotel told me that's what it was. So, yeah, exactly. Okay. Here we go. So this is what I think the public sees, policymakers see, and others in the community see about how children develop. And so here are the factors. There's fate, there's free will, there's parents, there's genes, but we don't really know what they do in terms of doing anything. The brain and child development, there's environment. They go into this thing that we typically identify as a black box. That may be the case in terms of toddlers and adolescents. And you either get a successful child or an unsuccessful child. And that's sort of the narrative that I think is prominent. But I think things are changing because I think that in general we figured out much better ways of communicating the science. I'm part of the National Scientific Council on the Developing Child, and essentially it's a group of scientists, neuroscientists, developmental psychologists, 2 pediatricians, economists, figuring out how to talk about early brain and child development. So I'm going to give you both common misconceptions and the core story to set up what you're going to hear from the other speakers. So here's some common misconceptions about child development that I even heard this week. Okay, children are, anybody want to guess? Sponges. Does anyone believe that? Get out. Now. Okay. 80% of brain development occurs by 3. No. Does anybody ever interacted with a pre-adolescent or an adolescent? If you believe that 80% of brain development is done before that time, right, we're in big trouble. Bad stuff happens. You just have to have rugged individualism. That's actually a cultural narrative in the United States, and it's problematic because resilience is not about rugged individualism, being able to bounce back from adversity. There are actually skill sets that we'll talk about in a minute. And then ready to learn is all about, right, cognitive development, but you'll see that social, emotional, and cognitive development are inexplicably intertwined, and you're going to hear more about that. So the core story of development is the following. Child development is the foundation of prosperous communities. Brains are built over time from the bottom up, so skill begets skill. Basic skills beget more complex skills. So that means that basic circuits that underlie function are actually built first before more complex circuits are laid down in the brain. The process starts prenatally, but I'm not allowed to talk about prenatal development. I can only start at birth. Genes and experience together build brains, and in particular, because humans and all vertebrates are social creatures, but humans are very, very social creatures, that interactions that drive those experiences are so critical in terms of brain development in all domains, not just in social behavior, but in cognitive development as well. And I've already mentioned this, that they're inextricably intertwined. That's hard for me to say. I'm from New Jersey. Toxic stress, I'll talk about a little bit, damages brain architecture. It has real biological effects. We're talking about early adversity, abuse, and neglect. And I won't mention this again, but neglect, according to Health and Human Services and CDC, frank neglect is actually comprises about 80% of what we would define as early adversity for birth through 5 years of age. which surprised a lot of people. And again, resilience is not an internal character strength, but rather is built through combined impact of genes and environment. I'm building skill sets, just like we build skill sets for our sets for our sensory and motor functions. These are skill sets that can be built. And for many functions, the brain capacity for change decreases over time, but the brain doesn't develop synchronously. All skill sets don't come on board at the same time, right? So some things are on board very early and are patterned and are going to function just like they are in the adult very, very early. And others take quite a long period of time to develop, such as executive function, which I'll talk about in a minute as well. So our genes and ultimately developing brain architecture influenced powerfully by positive early experiences and negative ones as well. So what the brain is fantastic at, and it's why I became a developmental neurobiologist, is that it builds a structure with a lot of genetic information. We have 22,000 genes in our genome, and we use all of them in the brain during development. They're literally all expressed at some period of time during brain development. The blueprint is laid down, but it uses experience to further its own development, which is really quite remarkable when you think about it. So it takes in information and utilizes that. It lays down circuits to prepare the organism to be able to deal with what it thinks the organism is going to have to manage with later on in life. And I'll give you a few examples of why that is the case. And then, an analogy would be genes provide the hardware, but early experiences is the software that drives the system. But keep in mind this, genes are not immutable. Genes are regulated by experience. They turn on and off based on the experiences of the individual. And I think that's really an important concept to think about in terms of development. So if you look at a structure like the cerebral cortex, which is where all the higher functions occur, it expands most dramatically in primates compared to other vertebrates. Those are brain cells. Beautiful drawings of brain cells, actually done by Dominic Perpa at Albert Einstein College of Medicine, and was famous for displaying how the brain changes over time. That's what it looks like in a newborn. The same number of neurons are here in this picture. It's an optical delusion or an optical illusion. What happens is that the number of neurons are not added. Those are all set by birth, except for a few very limited areas of the brain that continue to add neurons. I'm not going to talk about those, but almost all the neurons that we have are already there before birth. Right? What happens is that the neurons grow, and they make connections to form the circuits that underlie the behaviors that we're interested in. This is what it looks like at 6 months, and this is what it looks like at 2 years old. So that 2-year-old who's quite obstinate has a lot of brain cells to be able to do the kinds of things that you talked about, Mark. So if you look at what happens between birth and puberty, this is what happens. Now, it's not that a 14-year-old is in a degenerative mode. Some people look at it and say, now I understand that teenager. But it turns out that we make about 40% more nerve connections than we end up with. We get rid of, just like in your garden, you thatch a garden, you get rid of the connections that are not used through this experience-dependent process, and we'll talk more about that.
A child's experiences during the earliest years of life have a lasting impact on the architecture of the developing brain. Genes provide the basic blueprint, but experiences shape the process that determines whether a child's brain will provide a strong or weak foundation for all future learning, behavior, and health. During this important period of brain development, billions of brain cells called neurons send electrical signals to communicate with each other. These connections form circuits that become the basic foundation of brain architecture. Circuits and connections proliferate at a rapid pace and are reinforced through repeated use. Our experiences and environment dictate which circuits and connections get more use. Connections that are used more grow stronger and more permanent. Meanwhile, connections that are used less fade away through a normal process called pruning. Well-used circuits create lightning-fast pathways for neural signals to travel across regions of the brain. Simple circuits form first, providing a foundation for more complex circuits to build on later. Through this process, neurons form strong circuits and connections for emotions, motor skills, behavioral control, logic, language, and memory during the early critical period of development. With repeated use, these circuits become more efficient and connect to other areas of the brain more rapidly. While they originate in specific areas of the brain, the circuits are interconnected. You can't have one type of skill without the others to support it. Like building a house, everything is connected, and what comes first forms a foundation for all that comes later.
So you just needed to you hear that video. I didn't have to talk for the first 7 minutes of this. So remember the following. Development's not a blank slate. There's already a foundation laid at birth, and that foundation of brain connections are really established to be able to allow the infant to begin to interact with its environment, and have experiences in a very meaningful way. And so you'll hear much more about specific milestones of infant and toddler development, but essentially sensory systems are mapped and set up very early. Why? Because the only way for the infant to be able to interact with its environment and understand experience and gain experience is through using sensory modalities. So visual, auditory, tactile, somatosensory, olfactory, all of those are established very, very early. And there are critical periods of experience that are required in order to set up the auditory maps as well as the visual maps. And if, for example, if a child is born with the lazy eye amblyopia, there's a period of time during which we can correct that because the brain is plastic enough to be able to change the connections. So sensory circuits form first, followed by motor and language, and then higher cognitive function, you can see, take a much longer period of time to develop. Something as complicated as executive function, which you've heard about, and the components that make up executive function are listed here, take a much longer period of time to develop through adolescence into early adulthood. And notice, because I'm older, I refuse to have this line drop. Right? I won't do that. So executive function takes a long time to build. There's skill sets that have to do with this, and in fact, education systems and other systems are recognizing how important these elements are in terms of building the brain in a way that allows an individual to be emotionally regulated, a problem solver, and somebody who can be productive in society. So here's the culprit. This is how nerve cells communicate with each other. It's called the synapse. And I'll show you the curve about why people think that brain development is done at about the age of 2, because about 80% of the synapses that we're going to build end up being put together by the age of 2. That's what it looks like. These beautiful, isn't this gorgeous? Isn't it amazing? These beautiful little circles here are vesicles that contain neurotransmitters. You've heard of some of them, like dopamine, the reward transmitter, serotonin, acetylcholine, and the neurotransmitters are used to communicate from one nerve cell to another. And over time, this is what the curve looks like between the ages it starts in the 3rd trimester, between the ages of birth and about 2 to 3 years of age. We get up to our plateau, and if you count how long it takes to get here, which is pretty fast, it's about 700 synapses that are being made in the cerebral cortex of an infant per second. So snap your fingers. Snap your fingers. That's 7. Okay, so that's, you're watching an infant. You're watching your grandson. He's about done. He's 2 years old. He's got about 3 more days of adding synapses. This plateau doesn't mean that nothing's going on. It just means that the net change in the numbers of those synapses is not changing, but they're maturing in ways in which they can communicate better and more efficiently. And then there's a decrease, and we really do lose 40 to 50% of the synapses that we make, and this occurs through the period of the puberty. So 80% of brain development does not occur by the age of 3, right? It just doesn't. The other thing that occurs is this process that we call myelination. We wrap the nerve fibers in an insulated material that allows information to flow much more dynamically and much more precisely. This begins just after birth, and it continues, fortunately, until about your 5th or 6th decade of life in certain parts of the brain. It's not synchronous. Your frontal lobe, which has to do with executive function and reasoning, that continues to myelate into your 5th or 6th decade. But there's a lot of myelin, a lot of this insulation that's laid down to allow information to be processed much more efficiently. So when you see skill sets coming online, That means that the information is being processed much more dynamically and efficiently by those synapses that I showed you. And part of the reason is this other really important postnatal process called myelination. Nutrition has a major role in all of these events in terms of providing what's necessary for healthy development. Remember, I told you, no matter what kind of experiences, positive or negative, if they're powerful, they will have a powerful impact on the brain architecture that I've talked about during this period of time. So let me give you data from one experiment. So this is the auditory map of a young rat, right? And the colors just represent frequencies that that rat can hear. So this is, while the rat's with its mom, it's very young, hasn't gone through weaning, hasn't gone, puberty's a month away. And the colors just represent high to low frequencies. But you can see that the map is actually quite large. And what happens over time, now that you're expert developmental neuroscientists, is that a lot of these connections get pruned away. The rat hears all these different frequencies and sets up this beautiful map. Look how precise this map is. Blue, yellow, and red segregated. It can hear all these different frequencies. But if you raise that infant rat in hearing only one kind of frequency, let's say the red frequency, what's that map going to look like forever in that rat? As an adult, it's going to look like this. Here we go. Because the auditory system, while it's being built, while it's creating its map, only hears that one frequency. That's what it believes it's going to hear for the rest of its life. Why would it care about blue or yellow frequencies if it's only hearing red frequencies? It would be a waste of time to build circuits that would hear these others if it never experiences it. So this is a really powerful example of why experience is so important. Social, emotional, cognitive, skill building are interconnected. I've already
The key to forming strong
Where are the children located in these frames? Where are they located?
Close to their
Are they by themselves?
No, close to their
On
parents.
they're on the adults' laps. There's contact. It's a multi-sensory experience. It's auditory. It's visual. It's somatosensory. All really important in terms of learning what are complicated skill sets. So children are not sponges. They're not placed in a room. They're not going to learn that way. None of us learn that way. And keep in mind this. This is your neuroanatomy lesson, right? So this is some of the circuitry that's involved in memory and learning. The hippocampus, the amygdala, parts of the frontal lobe are shown here. Watch carefully because I'm going to show you the circuitry that's involved in fear and anxiety, which has to do with emotional regulation. There it is, okay? It's literally the same circuitry, right? It processes information differently. But when experiences come in and can damage those parts of brain architecture, it's not just affecting emotional circuits, it's affecting the same circuits that have to do with memory and learning as well.
Learning to deal with stress is an important part of healthy development. When experiencing stress, the stress response system is activated. The body and brain go on alert. There's an adrenaline rush, increased heart rate, and an increase in stress hormone levels. When the stress is relieved after a short time, or a young child receives support from caring adults, the stress response winds down and the body quickly returns to normal. In severe situations, such as ongoing abuse and neglect, where there is no caring adult to act as a buffer against the stress response stays activated. Even when there is no apparent physical harm, the extended absence of response from adults can activate the stress response system. Constant activation of the stress response overloads developing systems, with serious, lifelong consequences for the child. This is known as toxic stress. Over time, this results in a stress response system set permanently on high alert. In the areas of the brain dedicated to learning and reasoning, the neural connections that comprise brain architecture are weaker and fewer in number. Science shows that the prolonged activation of stress hormones in early childhood can actually reduce neural connections in these important areas of the brain at just the time when they should be growing new ones. Toxic stress can be avoided if we ensure that the environments in which children grow and develop are nurturing, stable, and engaging.
So remember what I told you, powerful experiences, negative or positive, will have an impact on how the brain gets wired up. So here's an amazing experiment that was done by Seth Pollack, a student of his, at the University of Wisconsin back in the early 2000s. They asked children, they were about 3 or 4 years of age, I think 4 or 5 years of age, but they looked at a community sample and children who were physically abused. And they said, tell me what you see in terms of emotions and tell me where it changes from one emotion to the next. And for both groups, when they looked at happy to sad or happy to fearful, they went about halfway across before they said, this is where the transition is. So they had no problem with that. Right? If you look at the community sample in terms of being able to distinguish the transition from angry to fearful, angry to sad, it's about right here. It's about 50%. If you look at the children who were physically abused, it's about 80%, right? So think about that in terms of what it means and what that child is seeing. We socially engage. We interact with our environment based on how we read signals, social signals. They're seeing the faces differently. Why? Because they've experienced this, just like that rat experienced that auditory information and wired it up in a certain way. They overrepresent anger, probably because it's a survival mechanism, right? So powerful experiences, positive or negative, are really critical. Why does experience have a long-lasting effect? Well, we know now that the genome that we inherit from mom and dad can be changed chemically over time, something that we call epigenetics. Those chemical signatures can actually change how a gene is used during time in development, when and where it's expressed. And also, which I've already told you, that experiences can change either in a positive way or a negative way, those synapses or nerve connections that actually change how circuitry is put together and how it functions over time. Right, so what is neuroscience telling us? And I'm almost done. Well, normal brain plasticity, which is influenced by experience, declines over time. It doesn't mean that it's eliminated, because many of us in this audience are still learning. But the amount of energy it takes for us to do something completely new, like learning a language, for example, takes a lot more energy, and in the end, if we wait, we just don't acquire that skill set as well. So these early years are really critical, and the ages from 0 to 2 lay down that foundation for experience to have very positive effects in terms of wiring the brain up for a lifetime. So I'm done. These are my granddaughters. This is my favorite shirt of all time. She never she never cries when I hold her. So thank you very much. I'm done. You're welcome.
Well, I think we're off to a good start. Our next speaker will be Dr. Lisa Shulman, who is Associate Professor of Pediatrics and Director of the Infant-Toddler Team at the Rose F. Kennedy Center Children's Evaluation and Rehabilitation Center at the Albert Einstein College of Medicine. Since 2004, Dr. Shulman has been the director of the RELATE program at Einstein, which is a state-of-the-art evaluation and treatment program for toddlers through teens with autism spectrum disorders. And she is going to focus on milestones for child development. That is, what should we be looking for between birth and 2 years. So please join me in welcoming Dr. Shulman.
Okay, our outline for today is we're going to go through some principles of development. We're going to look at the newborn's capabilities. We're going to start with motor milestones and then move on to communication milestones. And we'll finish up with when development does not unfold as expected. Okay, here are some principles of development. This builds nicely on what you were just hearing, I think. Skills build upon one another. When I'm teaching the residents, I usually take out the growth curve that shows the height and the weight and how they increase over time, and that's what happens with development. Developmental milestones should unfold in order. They shouldn't skip around. Development should always proceed forward for young children. They should not take steps backward or regress. Development is influenced by experience. Thinking specifically about motor control in young children, it should be symmetric. And communication grows out of social awareness. Okay, here's our subject. Point A, the newborn. He doesn't look too capable. Doesn't seem like he's going to have too much he can do, right? And here's point B, the toddler. This guy is busy. How does that happen? Okay, let's start off by looking at what the newborn comes into the world with. The newborn is pre-programmed to grow, to move, to vocalize, socialize, and learn. He comes out, kicking his legs, batting his arms in seemingly uncoordinated random movements. Many of those initial movements are actually governed by reflexes or involuntary responses. For example, the startle reflex. You drop a baby's head too quickly and the arms come out as if to grab, is pre-programmed. It will be present from birth and gradually disappear and be gone by 4 months. The ATNR, or asymmetric tonic neck reflex, is another reflex that when you turn the child's head to the side, this is a fencing movement, it's called. When you move the child's head to the side, the arm that's by the chin extends and the one that's by the back of the head flexes as if they're fencing. So the baby doesn't have total control of his own body. These reflexes determine in certain ways how he moves for those first 4 months. Grasp, something touching the palms or the soles, will lead to the toes or fingers curling. Head writing, if you move the baby's head off kilter, he or she will make an effort to straighten it out so that his world won't be crooked. And stepping, touch the baby's soles of the feet to a surface and he'll make stepping movements. The newborn is also ready to learn. Much of that learning, as we were hearing, comes through the senses. He comes out able to see and hear. But for seeing, he needs sharp contrasting patterns, and he has a limited ability to track movement or objects in an arc. He can best focus on objects that are 7 to 12 inches away, and that happens to be the distance of his mother or father's or grandfather's face as they're feeding him. He's pre-programmed to have that social connection. He likes to look at faces more than any other pattern or shape. Babies come out hearing at birth, and they seem to show a particular preference for the human voice over other sounds. And in fact, they'll try to orient their head toward voices. And they'll imitate some facial expressions, simple things like yawning, smiling, frowning, after they've seen a parent do it over that next half hour. As the newborn experiences the world through sensations, his brain takes it all in and attempts to make sense of it. Connections, those same pictures you were seeing, develop. And the more input he receives, the more connections form. Learning and fine-tuning continue through sensory motor exploration and play during these first 2 years. Okay, so let's move on. Let's start with the motor milestones, birth to 4 months. Okay, the baby came out looking like a blob, needing the parent to support their neck, And that first motor milestone, as those primitive reflexes that are controlling the baby's movements are resolving, volitional movements emerge. And the first volitional motor act is head control. This is the pull to sit maneuver. And over time, the baby goes from having a completely lagging head to being able to keep the head not only even with the body, but leading. That's going to happen by 4 months. Now, head control is then followed by rolling over. And while baby's gross motor skills are developing, in those first couple of months, baby's also taking time to really explore her hands, bringing her hands and often her toes to her mouth, looking at her hand to say, this is a part of my body. If I do things, I can control it. And then being able to swipe at objects and grab at objects by 4 months. Motor control develops from the neck downward. So we saw that first the neck control comes into play, then rolling over involves having control over the upper torso. The next motor skill is sitting. Baby becomes more stable when placed in sitting, and it's actually very nicely illustrated by this string of babies in sitting. Okay, this is a little baby. This is a 4 or 5 month old. She needs her arms to maintain herself. Her back is not straight. She's like a complete C. Now, what's going to happen, her control of her back is going to go down her back, and this baby is a little older and able to sit with a straighter back. And this baby can completely control his spine. He doesn't need to rely on his arms to basically protect him from falling. So those hands are available to play. Moving on to 5 to 9 months. At 9 months, many babies are pulling to stand. They may start to crawl as well, but this happens to be a skill that is actually not considered a milestone because about 15% of babies don't crawl, and there are different crawling styles. This baby's commando crawling. She's a very little crawler. She can't get her tummy off the ground. This bigger boy, he's in the typical quadruped hand, and legs are moving very, very symmetrically. And this little girl as well. When babies crawling like that, they're leaving the room. They're really pursuing their own agenda and interests. They're also now pulling erect, pulling to stand initially in the crib, and then pulling to stand on the coffee table, and walking, holding on, or cruising. Experience and temperament will impact on how quickly the baby moves now from that stage to walking. So for example, babies who are held and not given an opportunity to be on the floor will often walk a little bit later. Babies who spend a lot of time in a baby walker and aren't given free rein will also often walk a bit later. A timid baby or a nervous baby who has a bad fall the first time they take their first step out will probably take a step back and need a little bit of time to try again. Between 12 and 18 months, though, most babies do start to walk. And the new walker has a very distinct gait pattern. The legs are wide apart, arms are up to help with balance, and they don't bend their knees much. Now this boy, he's a little older. His legs are coming together, his arms are more under his control, and here's the little boy from the beginning. He's running. His feet are very close together, and he can use his arms for completely other tasks. Over time, motor milestones include the ability to have the balance to stoop and recover, and to do my favorite toddler pose, stooping and recover. And then toddlers like to squat while they play. No one else can do this, only little toddlers. Okay. And I like to refer to the phase of 18 to 24 months as being playground ready. The baby has gone from a lump to now walking turns to running. The baby is a toddler, able to go upstairs. We're gonna see some stair going up, going down, kicking balls, throwing things, and jumping. And again, the gait of a 24-month-old is quite mature. It really does look like a mature gait. It is narrow-based, the feet are close together, the arms are swinging, and it's got a heel-toe pattern. Okay, so boiling it down to what to look for: head control by 4 months, sitting by 9 months. And by the way, we've watched sitting get later since babies were put to sleep on their back, another example of how experience impacts on skill acquisition. And by 18 months, babies should be walking. Okay, let's move on to communication. So I think when it comes to motor development, most people intuitively understand that skills build upon each other, and a child isn't going to walk before she can sit, and these things need to occur in order and build upon each other. But for whatever reason, after all these years of doing this type of stuff with parents and in my social life, I'm amazed at how many people don't apply that same logic to language. Even though the child is making no sounds, making no efforts to communicate in any way, the parents often still think the child's going to open their mouth and talk in sentences, possibly tomorrow. But we can gauge how communication is going way before the first word ever appears by following the attainment of pre-language communication skills. We can follow that process along, nurture it, and anticipate difficulties so that we can intervene. Hold on a second. Language is the use of words in a structured and conventional way. But I'm using the word communication here because it's a means of connection between people for the purpose of exchanging information. You need two people to communicate. Communication is the functional use of language. And in order to develop, there must be social interest, social awareness, social interest, and social motivation. And it's actually that social component of communication that we can look for and monitor and nurture long before that first word. Social awareness can be gauged through engagement, attention to language, and communicative efforts. So why don't we look at the different ages and see how the baby manifests engagement, attention to language, and communicative efforts. Okay, I happen to love this video. Babies are born with social capability. As I had said, they prefer to look at faces and listen to voices over other stimuli. They match facial expressions. It is quite amazing what newborn babies can do. But by 2 months, when parents often have a sense that their child has woken up and entered the real world, look at everything a baby can bring to the interaction. This is an 8-week-old.
Can you follow the toy? Oh.
You hear the conversation that's going on?
I hear you. Oh.
That baby was so engaged with Mom. Their eyes were locked. She's smiling, he's smiling. He's vocalizing, she's vocalizing back, and they are having a conversation. This is a 2-month-old. By 5 to 9 months, babies are very attentive to people around them. And they show that interest and attention by where they're looking, their facial expressions, and their own actions, such as imitation. Again, it is amazing how early babies can do some of this. Okay, she's a ham. This girl loves attention. She is 7 months old. She can imitate. Okay. Babies learn through imitation, and this is happening very, very early. Okay. Now, in this same 5 to 9 month age range, baby is attentive to language. They're really paying attention to all the language in their environment. And the biggest clues we get is that this is an age where the baby, when you call the baby's name specifically, the baby should turn to you. Okay? They're not just responding to a voice. They are responding to a word they hear frequently, their name. So we can imagine that if you see a baby much older, 15 months, 19 months, 2 years of age, who isn't responding when called, it's really going to stand out because this baby can do it much younger. And at the same time, the baby's starting to follow commands with gesture, things they've been introduced to, things they've practiced.
Ella, look what Mama has.
Mom can direct her attention.
Yan. Vení con mami. Vení con mamá.
Babies this age, of course, they don't have any words yet in general, but they're using their eye contact, they're vocalizing and gestures, and they are building on the communication we saw in the little baby. Sorry, I can't find the... By 9 to 12 months, babies are very social engaged. They really want to have your attention all the time. They are very, very attentive to language and actually able to follow commands without gesture. Those initial commands are things they've been introduced to through routines. So this is something a parent can do by establishing routines. We're going bye-bye. Baby will hear going bye-bye, and the parent waving bye-bye about 100 times before one day the parent says, okay, we got to get ready, we're going to go bye-bye. And then the baby, without the mother's example, it's not imitation anymore. The baby hears bye-bye, and there they are, bye-bye. Oops.
Round and round the people on the bus go up and down.
Okay, he's not watching her. He knows these words. Okay, he's 9 months old. And the important communicative skill that the baby acquires now in this age range is the all-important point.
Where is it? You point. Point to it. There it is.
Took us a long time to get that video. But the pointing is a very important, very specific gesture. I want that. Look at that interesting thing over there. You only do those things if you're communicating with someone, and it is a two-way street. And it's also right around after the point that the first words typically emerge. Now, in the 12 to 18-month range, baby is socially engaged and more mobile, and she is actively exploring her environment and chasing after things of interest, following mom or dad around, curious about everything and primed to imitate. Functional play emerges. Now at this age, baby's no longer putting things in their mouth primarily, not banging things, not throwing things. Now this is play that incorporates language, and the parent being on hand to use that language is modeling that language that the baby can then imitate and then call their own.
Gracias.
This is a very little baby, but the baby understands this doll is meant to be a baby, and I'm going to feed this baby. That symbolism that goes along with language understanding and language production. Okay. The attention to language in this age group is manifest by understanding more commands.
You see. Where's the baby's nose?
Look. And this is the age range in which most babies begin to produce gradually a handful of words. Initially, those first words are for wants. Baba, juice, mama. And then as part of routines, the wheels on the bus go up and down, pick me up, mine. Between 18 and 24 months, in general, you have children who are very, very socially motivated. They're no longer needing to be wooed They initiate the social interaction and the showing behaviors. They want constant attention. They're constantly tapping mom. Oh, look at this. I want that. How come she got that? And more elaborate pretend play goes along with that capability.
Okay. And a knife. Okay, should we turn on the stove and cook?
There's a complex series of events that this child's been watching mother do and now able to carry out. The toddler's attentive to language, understanding a tremendous amount of language, attentive to books and others' conversation. This is the age at which you have to be very, very careful about what you say, because this very nosy toddler is going to repeat it at the most inopportune of times. Communicative intent is present with a vocabulary of 200 words and growing, and language is used for a much wider variety of purposes. No longer just to ask, not to label. I love this one. Ooh.
Yeah, what should I do? You need bubbles.
Okay, so look how far the toddler has come in 2 years. He's running, he's talking, he's socializing and playing. In kind of thinking about communication milestones to look for in terms of concerns, by 9 months, a baby should be responding to names specifically. By 14 months, a baby should be pointing to indicate what they want and also to show things of interest. By 18 months, a baby should have a handful of words. And by 24 months, what's supposed to happen between 18 and 24 months is really amazing. There should be new words every day, and there should be word combinations, which generally come when kids have 50 words. Okay, so we have to start thinking about what happens when skills don't exactly unfold as expected by remembering that there's a range of typical development, especially in this age group. And on the other hand, the period of birth to 3 years is a vital and critical developmental window when we don't want to miss that opportunity to intervene. So if development has gone awry and a baby or toddler is not demonstrating the skills expected, we want to catch those difficulties as soon as possible and initiate intervention. Delays in these skills can signal a variety of issues. I actually think at the top of the list we should put general health. Babies who are having problems with their development, first and foremost, we have to think about their health. Sick babies often do not develop appropriately. Then, dividing things out into motor and communication, motor delays can often be red signs for neuromuscular problems, genetic or brain abnormalities, and cognitive impairment, significant cognitive impairment. Communication delays, first and foremost, we have to think about hearing problems, specific language delays, or more general developmental delays, or autism. Here's a few quick clinical scenarios. Okay, first, I'll say that babies traditionally walk upstairs erect before they walk downstairs. I mean, you can picture the scenario that the baby managed to get upstairs somehow and now is stuck. As an example of that. But what happens if you see a 24-month-old toddler who can go downstairs erect, but not up? What does that mean? We always take toddlers on the stairs to look for just that, because if a baby can't go upstairs and can go down, going upstairs requires a lot more strength of the proximal muscles, and it's generally a sign of weakness. It can be weakness due to general health problems, but it's also a very sensitive sign for muscular dystrophy, specifically Duchenne's muscular dystrophy. And probably in my career, we've picked up about 3 cases by just this very simple thing, that development is happening out of order. Kids are supposed to be able to go upstairs before they go downstairs. But if a baby or a toddler can't, that is meaningful information and suggests additional medical workup is needed. Okay, the next case, a 21-month-old who does not respond when called by name. Okay, now we were looking at the videos. 9-month-olds respond to name. Often 6-month-olds respond to name, to be honest. So it is really dramatic when I go out to the waiting area to bring in a child to my office and I start calling their name. I call their name in the waiting area. I call them by name all the way to the office. And if I don't get any reaction, of course, I confirm with the parent that I'm calling them the name that they actually use, but I ask the parent, Call him. How do you get his attention? And it's not unusual that I'll have children in my office, 21 months of age and older, who there is no way to get their attention by calling their name. Initially, parents come with the chief concern, perhaps the child is deaf. Although then when you explore it further, they'll say, well, he hears the most minute electronic sound in the other room. It's a very concerning sign for autism because children with autism often do not pay attention to language. And if they don't pay attention to language, they don't learn language. A 24-month-old has many words, has language. He can label oval, rectangle, alligator, tow truck. But he doesn't point or use any words to let his parents know he wants food or anything else. He only cries. Now, we were saying that that point's supposed to come in 12 to 14 months. And using words for wants is going to be the first thing words are used for, and that's certainly by 18 to 20 months. This boy has unusual first words. So he has a disconnect between language and communication. He has language, but he doesn't seem to have communication. And that also would raise concerns regarding the possibility of autism. So I think I'm going to stop there. But that was our introduction to our amazing infant to toddler years.
You must have a lot of fun during the day that you work. Okay, so our third and final speaker is Dr. Lisa Freund, who's chief of the Child Development and Behavior Branch at the Eunice Kennedy Shriver, National Institute of Child Health and Human Development at NIH. She's a developmental cognitive neuroscience known for her neuroimaging studies with children from different clinical populations, and she's going to present an overview of the NICHD investments and research priorities for children between birth and 2 years old. So join me in welcoming Dr. Freund.
Okay, so that's a mouthful. Eunice Kennedy Shriver, National Institute of Child Health and Human Development. And I'm the chief of the Child Development and Behavior Branch. And it's, we use acronyms in government. This is part of the NIH. So this, we usually refer to it as NICHD or the Child Health Institute. And, but you can call me Lisa. So, okay. All right. So NICHD, or the Child Health Institute, is part of the National Institutes of Health, which is the world's largest supporter of biomedical, behavioral, and social science research and training. It has about a $30 billion budget, and it is comprised of 27 institutes and centers, of which NICHD is just one. So NICHD is a little different in that it is not dedicated to one specific disorder or disease. For example, mental health is really focused completely on mental health issues. It focuses on development, and it focuses on development from conception through adulthood. And it also looks at when development goes awry or atypical development. So our research mandate is very broad at NICHD. We look at investigations and support research for all stages of human development. We're looking to improve the health and well-being of children, families, and communities, understanding intellectual and developmental disabilities, and understanding all aspects of typical development, which you've been hearing about today, and social, physical, and behavioral rehabilitation. We support both basic, meaning in the lab type of research, and applied and translational research, the type of research where we're trying to do interventions when it looks like we need to help developmentally. We have a website, of course, and it's very easy to get to. kind of hard to move around in, but if you click enough, you'll find some interesting information, so particularly if you start looking at news and media coverage of different things that we're involved in. Right here, they're talking about keep her happy while she's up and keep her safe while she sleeps, part of the Back to Sleep campaign that's been going on for quite a while to put infants on their backs when they sleep, to where we see that when we do this, we see a much lower incidence of SIDS or unexplained crib death. This is a horrible slide that you can't really read, but I just wanted to point out that when we're talking about the part of NICHD that has to do with funding research for researchers out in other places, other universities and research centers, not within the NIH, but outside, like Dr. Levitt, that we have these different branches, and these are the areas we're covering. Here's my branch, Child Development and Behavior branch, but we also have a branch on very basic research in developmental biology, gynecological health and disease, contraceptive discovery or fertility and infertility. Intellectual and developmental disabilities has a branch of its own. Maternal and pediatric infectious diseases, pediatric growth and nutrition, population dynamics. We have a new branch, pediatric trauma and critical illness, looking at procedures in ERs and how to deal with some very intense critical illnesses that young children can be subject to. And pregnancy and perinatology branch. So you can see we have this tremendously broad and breadth of research that we support. In my branch alone, we have 7 different programs looking at many aspects of development. Behavioral pediatrics and health promotion. That's looking at working with parents with their children in best practices for parenting, looking at risky behaviors and keeping children, and also in keeping children safe. My program is cognitive development and behavioral neuroscience and psychobiology, with an emphasis on looking at how brain function and behavior are correlated, and looking also at psychobiology, which involves animal models to help us look more closely at brain development. We have a program in early learning and school readiness. What do you need to do and to help your child at very early ages to be ready for a structured learning environment? We look at language, and this is typical language development, bilingualism and biliteracy, mathematics and science cognition, and math disabilities, reading, writing, and related learning disabilities, we support research there, and social and emotional development in child and family processes. So you can see this is a lot to be covering. The level of research funding, I was asked to talk about what are our investments for development. So overall in ICHD research funding, now this is just for grants to outside universities or research centers. It runs about $900 million a year, and it's been pretty steady over the last 5 years. When we look at trying to see what are we investing in research that targets the age range infants to 2 years old, that starts to get a little hard. And one of the reasons is the NIH doesn't really categorize or collect data on the ages of the individuals being looked at in the research in any kind of way where it's in a database. One has to go in to the grant and pick out what ages are being looked at there. We know if they're children, we know if there's adults, but we don't know the ages. So we did a rough calculation, and we found that maybe about 107 million, about 12% of the overall research funding is going to that age group, okay? And that's in the fiscal year of 2014, that's our latest data. The number of grants is about 201. out of, which is about 10% of the overall number of grants that were awarded that year. It's probably an underestimate because I was just looking to see if I could pick out infant or that age range to 2 years old quickly, and sometimes that's not easily determined. The types of things that we're funding. You can see that most of our grants, the highest number of grants, are really looking at particular physical conditions in children or physical ailments and how that may be impacting development. Another area is language development. More grants are being there in 2014. Cognitive development, behavior development, and emotional development, but also global health delivery in that age range, looking at health practices in other countries and helping to improve them, growth and nutrition grants. You'll see that infant pharmacology is actually quite low, but it's going to be growing. I think it's a fairly new program. Obesity and parenting. So you can see there's quite an array of areas relevant to this age range, focusing the research. So what are our research priorities for infants through 2 years old? Well, there's a large initiative looking at newborn screening and diagnosis. In particular, being able to screen for conditions, genetic, congenital conditions at newborn that we have an intervention for, that can be treated. We have a strong emphasis in brain development. And here again, I put in parentheses connectivity. We've been talking about that. It isn't just a matter of knowing the size of the different areas of the brain necessarily. It's how they're connected and how does that change over time and maturation, especially in this time where it's growing so rapidly between infancy and 2 years old. And understanding as the brain changes, how is that associated with changes in behavior? That's a very thorny problem that's very difficult to do. We have a lot of interesting data that's come from adults, but with this age group, we're just touching the tip of what's there. There's a lot to understand about parenting and healthy brain development, and I think that was talked about quite a bit by the other two researchers. And I think this is an area that we want to explore more, that the environment that caregivers create for their young infant and toddler has such an important impact on the health of the brain and the success and competence of the child eventually. We do have, we're interested in very early number or quantity sense and predictors of math difficulties. Yeah, there's research looking at that. Early language acquisition and communicative gestures. We know a lot about the milestones, and you did a lovely job of pointing those out, but we need to understand more about how that's achieved in development and what are the underlying brain structures and connectivity supporting that. And of course, the environmental, caregiving, and neurobiological factors underlying the development of self-regulation, which was talked about by Dr. Levitt a little bit in terms of executive function. But self-regulation, we're talking about at this age, the ability to begin to self-soothe when you're an infant, be able to settle down. And initially, the parent is doing that or the caregiver is doing that. Eventually, the child will learn to do that him or herself or be able to modify some of that response. Other types of self-regulation, being able to inhibit touching something that they're told is dangerous, that type of thing. So self-regulation starts developing, and understanding how caregiving impacts on that is very important. And of course, we want to understand very early predictors of autism spectrum disorders. If waiting until we can identify some of the indicators, as you were mentioning at the last talk, maybe we could find earlier predictions. Are there biological factors or what we call biological markers? brain structure signatures. Are there other types of predictors, maybe behavioral predictors very early on, for having us be able to intervene earlier? We're interested, of course, in much of the developmental disabilities, such as those associated with Fragile X syndrome, muscular dystrophy, Down syndrome. There's been a long history of focusing on premature birth, both prevention and intervention. Prevention, treatment, and management of the physical and the psychological trauma for critically ill and injured infants and children. This is part of that new branch that I was telling you about, and a whole new focus for the research at NICHD. And finally, and this was mentioned by Dr. Levitt, adversity, poverty. And by adversity, I mean also the toxic stress that comes with it, but poverty, stigma, discrimination, exposure to violence or abuse or neglect, and its interaction with genetics, parenting, or the environment, and those effects of that interaction underlying brain development and function. Understanding that whole piece is of great interest, and we don't know enough yet. We also have a lot of resources we've developed for research with infants and young children. For instance, I forgot to put in here some existing databases we have of neuroimaging of children, neuroimaging scans of infants through actually 18 years old, of both the structures of the brain, as well as the connectivity in the brain. The databases we have available are available to researchers to use, and we have not only the MRIs or the brain scans of children as young as infant to 2 years old available, but also a lot of assessment data on behaviors and whether they've met developmental milestones, etc. So that's available for other researchers to use as well. And we have now, there's something called the Human Connectome you may have heard about, that's been looking at adults with a very special technique of looking at the brain with exquisite detail and beautiful resolution in adults. And now we're bringing this into a developmental focus. And there's a call for research now for looking at infants, and we're calling it the Baby Connectome. And we're looking for infants from newborns through 5 years old. We also have database resources for other types of researchers, but in language development, large databases of samples of language development across different periods of life. Early child care study we have that looks at the effects of child care. We have a wonderful videotape library of various different types of research protocols, and also videotape data of social interactions with infants and mothers, or usually it's mothers, caregivers, as well as toddlers, that were done and being stored by researchers who now are sharing with other researchers who can then code that data as they like, or investigate the coding that was done by the researchers originally with those videotapes. I just wanted to talk about one specific example just to show you the type of research. Remember, this is where your money is going for research. And there's a lot of people who have wanted to hear more about, where's that research going for development. So here's an example that was a very interesting longitudinal, meaning it really looked at children over time as they grew, and started very young at infancy. And it was funded not only by NICHD, but also the Department of Education, another institute at NIH, the Institute of Deafness and Communication Disorders, and also the Center for Diseases. I'm sorry, excuse me. And that's really important because this was a huge project. It involved 20,000 children being followed. It required that kind of collaboration across agencies in the government to be able to fund this for looking at development with a real focus on language. And Amy Weatherby is someone who is involved in that. And one of the questions was, instead of waiting to see if a child is delayed in language and at risk for learning problems, is it possible to evaluate skills that are early predictors of language development? And these are behavioral skills. We don't have the biological markers, as I mentioned, or know what the biological brain configuration is to indicate of a child who may have a language development, who appears to be developing normally in infancy but has a language development problem. So what they came up with is they found that if you look at gestures that a child can make between 9 and 16 months, these communicative gestures, that it will predict language 2 years later. These gestures are things such as shaking the head or giving something, reaching, raising the arms, showing. Again, remember, this is all that interactive type of communication. Points with the open hand or taps, claps or blows a kiss, points with the index finger, etc. These types of different gestures are really important indicators of later language ability. And in fact, what they found is that children should use at least 16 gestures by 16 months. So what they came up with is a graph like this, that you should be seeing this progression, that by 11 months, you're getting waving bye-bye, you know? That by 12 months, that you're getting the pointing, that you've got pointing with the index finger or shh, like that, and other kinds of symbolic gestures, as you indicated in the last talk about, you know, feeding the baby with a fork, pretend, that type of thing. Now, these aren't, these are something that would indicate to a professional or a parent that, hey, maybe we ought to check this out further. It is not a definitive diagnosis by any means, but it is a way of indicating maybe we should look at this further. And that's the type of research that is really helpful by getting us in there earlier if there is a problem to be able to help and intervene. Further research, again, I just wanted to say, is the richest moments for early language learning are really when the child and the caregiver are, are sharing their attention, this joint attention, that they are really communicating with each other, which we saw some beautiful examples of previously, and that the caregiver talks about the child's focus of attention. There's been a lot of emphasis on looking further at speaking a lot with your baby to help with increasing language development or making sure that development in language is on track. Because many parents, believe it or not, are not really used to talking to a baby. That they don't always talk back, and parents sometimes aren't sensitive to how a baby communicates back. But it isn't just how many words, it's how you do it, in what context, and that you are sensitive, basically, to what the child is attending to. So that's another example of the type of research that we look at. And we have a website that can tell you more about our research findings and various topics that may be of interest to you. And it's easy to find, nichd.nih.gov. And that's it. I thank you very much.
Thank you, Dr. Freund. So I'm going to just start it off with a question, and maybe two, but maybe not. But I'll invite those of you who have comments or questions to begin thinking about them, and there are microphones on both sides of the auditorium. We'd like you to identify yourself and give your affiliation. Maybe some of you have dual affiliations, such as you're a scientist and a parent, and want to gain some insight from both perspectives. So before we then break for our reception. So I have lots of questions, but let me start with Dr. Shulman. Is there any evidence that this developmental track that you showed us is affected at all by the presence of an older sibling in cases where the sibling may previously have followed these steps, or one who has had difficulty in following those steps. We talked a lot about parents and caregivers.
Yeah.
What about older siblings? Does that affect the learning or the motor skills of a younger child?
There are some studies about language that the overall level of language that the child's exposed to when there are many young siblings who have very immature language gives them less stimulation. And so sometimes kids who are one of several kids, a row of kids who are close in age, may have some initial delays in speaking on the basis of that theory, and there's some data for that. But, you know, I answer more in practical terms that I think having siblings around is great examples that kids then imitate. It's very motivating if your sibling has run off with your toy to move and get it. And so surely there's a lot of practical data that having siblings is very good for children's development.
Anybody else want to touch on that?
I mean,
Dr.
there's a long history in both in family development and school development, preschool development, that typically developing children are not impacted negatively by being in the same environment as children who have a developmental disability. It used to be back in the 50s and 60s until Susan Gray did the practical experiment of demonstrating that typical development is not impacted in a negative way. In fact, there are many positive factors that emerge that she and hundreds of other scientists have shown now that occur in the development of a typical child if they're in the environment of somebody who, of a child who might have intellectual disability or some other issue. So I don't think there's any evidence that there's a negative impact. In fact, there are positive ones.
Okay. Okay, let me ask the audience if you'd go to the microphones now, those of you who have questions. I just have one other quick question, and then I'll step aside for Dr. Freund. To what extent has your sort of research priorities, your agenda been shaped by interaction with the community, the research community, and the advance in instrumentation, the technology?
Well, what we do is we try to we don't just come in ourselves and just say, okay, this is what we're going to do, this is what we're going to do. We get our experts outside to come to conferences, scientific conferences, and we say, hey, in a certain area like language development in this age range, what do we know, but what don't we know? And that's really important for the experts to tell us what we don't know. And so that we can then know how to go out and say, hey, we need research in this area, because the experts are telling us now we don't know enough. And what technology has helped us with is, in particular, I think we were talking about this a little bit before we all started, is certainly neuroimaging has been a tremendous advantage for understanding the brain. And there are different aspects of neuroimaging that are useful for a very young age range that are being developed, not just the MRI machine. And also the eye tracking is a big boon for early developmental research, because eye tracking is basically one of the things that it does. It tells you where the child is attending. It also tells you somewhat about what the child perceives as novel or something that it's seen before. It gives you an insight into perhaps memory.
Okay, well, I see we have a number of people ready to ask questions, so let's go to our audience again. If you would identify yourself and your affiliation. We don't have lots of time, but nevertheless, if you'll make your questions succinct, perhaps we can get through all the people that are standing up now. Please, go ahead.
Good afternoon. My name is Felicity Crawford, Associate Professor at Wheelock College in Boston. My question is, how, if at all, do handheld devices impact children's cognitive development?
Well, we don't know for sure, but we do know that children, really before the age of 2, and most likely beyond, but that's what we have data on that I'm aware of. They're not learning as well from the media, electronic media, okay? If they're sitting there with the electronic media, with the parent, and they're on the lap, and they're looking at it together, well, then you're talking about something that's similar to reading a book. It's a social kind of learning situation, perhaps. But if the child's isolated and sitting looking at this electronic thing or watching TV, we're not seeing evidence that there's learning occurring.
Anybody else? Well, yeah, please.
We have a large waiting area in our center, and I used to go out into the waiting area and see the kids interacting with each other. Now it's not unusual that I'll go out to the waiting area and see each child beside their parent with their own iPad or on their parent's phone, and nobody's interacting. There have been recommendations by the American Academy of Pediatrics to limit use of these devices along with TV in kids under 2, and they certainly should be limited because they end up competing with actual interaction. And as we know, actual interaction has a way to capture kids' abilities and promote them for real functional skills. So I've gotten myself in trouble by saying this to a parenting magazine once, but I think it is important to limit these devices and, as was said, to do them with a parent.
Okay. Over here, please, Jessica.
Yes, my name is Jessica Wyndham, AAAS. My question is about language acquisition and brain development, particularly what the research might say about differences in children who are raised in multilingual or bilingual households as opposed to those that only have one language.
The bilingual research that we've seen and has come into our institute indicates that there may be a benefit in cognition in the ability to rapidly switch between, allows the somewhat better executive function abilities. The studies are small and more needs to be done to understand that better, but that's where we are now with that. And there does not appear to be any bilingual deficit or anything that delays cognitive development if one is bilingual or raised in a bilingual home.
What's interesting is there have been studies that have shown that there was some thought that there might be more limited vocabulary that was being learned in a bilingual situation, but it turns out that vocabulary complexity early on is identical to monolingual environments. It's just that the toddler is learning 2 languages at the same time, essentially splits the complexity between the 2 languages, and then it sort of takes off from about the age of 3, and they exceed monolingual individuals, obviously, because they're learning vocabulary in both. So there seems to be a mechanism in the brain to be able to handle the load, which I think is an interesting observation.
But I think that it is another one of those misconceptions to have on your list that coming from a bilingual household means you'll start talking later.
Yeah.
That is a misconception. That's correct.
It does. Yeah, it's not true.
Okay. Over here, please.
Hi, my name is Karen. I'm a scientist and a parent of an 8-month-old. I'm interested in research, what research has been done into how to reverse the course of the toxic stress that you talked about at later ages. And if anything's been, if there's protocols as a scientific term for when kids have a better ability to control their own situation, say later teenagers or early 20s, where they maybe have some more control over their situation.
So it's been, it's been a challenging area to develop in terms of developing, in terms of new interventions that are really effective in changing the course of development. I think, from my perspective, over the last 10 years, it's been very exciting to recognize that interventions that have been developed to target the child alone are less effective than when the interventions are multi-dimensional. That is, they're targeting both the child and the primary caregiver to learn skill sets, particularly in the area of social engagement, which is so important. So there are lots of studies now in the foster care system, for example, where what's called multidimensional therapeutic foster care has had a real positive impact in changing trajectories. So if you look at a child who has a history of being moved from family to family, unstable, and they get into a program with their sixth primary caregiver and they're in that program, the stability just takes off. So it can have very positive effects. But I think the recognition that development will take a positive trajectory with the recognition that there's a requirement for social engagement and interaction in any kind of therapy is really a sea change in the field.
Thank you. Please, sir.
I'm Ralph Nitkin from the National Institute of Child Health and Human Development, same place as Lisa. I'm here to keep an eye on her.
Can he ask a question?
I'm actually in the area of rehabilitation. It's a little
talk
different.
about his stuff.
But I think the talks we had this evening were very eloquent about the brain and the role of early input from parents and the importance of those interactions. But having said that, it creates a certain anxiety for parents because they figure, well, the more I interact with my child, the better they're going to be. And so how do you kind of strike that balance that doesn't drive the parents crazy, that tells them that this is enough, it's sufficient, and they don't try to be overachievers and start piping in music in utero and so on?
I will answer that.
I didn't say amount, right? You notice I didn't say amount because we don't have a titration scale for that. I talked about it about an element of a child's environment, of an infant and toddler's environment, which is so crucial for their development and the development of milestones. And we sometimes we tend to silo these things off. Oh, there's social development, and there's emotional development, there's cognitive development, and there's, and these, the brain doesn't work that way, I'm sorry. It just doesn't work that way. So it's not about titration, it's about recognizing that this is a natural part of who we are as human beings. And if you saw the milestones and the remarkable ability, even in infancy, of engaging, right? It happens so early. And I think that element is what needs to be recognized as being an important part of everything else that sort of comes in terms of developmental milestones and developmental trajectory. I think the other thing, which gets at the intervention issue, it would surprise me because I'm not an interventionist, but talking to people who do intervention research, there's this idea that interaction or serve and return is sort of the parent kind of directing everything. And if you think about your own experience, if you're playing volleyball or tennis or whatever you do, where throwing and catching a baseball, the game would get very boring very quickly if only you were throwing the ball to me. I would not be very happy with that. I'd like to share in those initiations and those interactions. So you see some of the qualitative issues about really a skill set of how to do this sometimes has to be discussed and taught as a skill set for parents. So not necessarily the amount, but understanding what the qualities are.
Dr. Freund, did you want to add
I
something?
think where some of this, especially out in the popular press, talking about amount of speaking, came from research where they were looking at some very toxic environments, very low SES environments where there are a lot of stresses on the caregivers, a lot of stresses in the neighborhood, and there wasn't a sense of even caregivers being able to spend much time interacting with their child. And so the amount of actual language and words spoken to the child was so minimal that there was a lot of emphasis on that. But so in the natural, in homes that aren't so stressed, that isn't an issue. But what we like to tell parents, and also I think what many of the interventions have shown, it isn't a matter of sitting down and then having time where you're going to interact with your kid and making sure you're doing a lot of that. It's really making sure you can engage your child in everyday activities. Okay? You know, you're folding the laundry. Talk about what you're doing. You know, talk about that towel, and I fold it this way. You know, you know, say the words to a very young infant. You're trying to talk about the actions, or maybe have the child engage with you with who's older. So it's really look at your everyday life and how to engage your child.
Okay, thank you. Jonathan?
Hi, Jonathan Drake, AAAS. I'm curious, given the profound and often lifelong consequences of these very, very early experiences, be they positive or negative, why do we not form conscious memories of them? And moving forward, in terms of developmental stages, where along that line is there a correlation between the formation of permanent memories and some of these developmental milestones that were discussed?
Yeah, that's an interesting question.
That is an interesting question.
Yeah.
Meaning we can't answer it. No.
Really interesting question.
I'll take the first half of it to basically say that I think the thoughts are that pre-language, those experiences and memories are coded differently. And with the advent of language, they're kind of lost, except for really traumatic ones.
Well, also we know that toxic or traumatic types of experiences very early on affect parts of the brain that have to do with memory. And in fact, some of the receptors are not functioning the way that they should and don't from then on. So that could be part of it, that there's a biological consequence of that in the brain.
You know, there's the other thing that, I mean, I would argue that our sensory systems have tremendous memories about what those systems experienced early on. That's how the sensory maps form. If they don't have memory of those experiences, then the sensory map wouldn't form, right? You couldn't hear all the different frequencies if there wasn't a memory trace that was held permanently in terms of being able to distinguish between low, middle, and high frequencies. So in the sensory world, I think that's exactly what happens. In the social emotional world, I think, you know, those circuits are developing over a longer period of time. Many of the experiences that are happening earlier are essentially in sort of the erector set building part of the process. Mm-hmm. And so it's over time tuning the system. But my guess is that the requirement to maintain those as specific memories just isn't that it would take too much energy, too much ATP to be able to hold all those online when you don't really have to, right? Because you're building this structure in a more gradual way.
Thank you.
Okay, one final comment or question, please.
This is for Lisa. Where can one access the neuroimaging database that you mentioned?
I'm sorry, how does one access it?
Yeah, where can one access the neuroimaging database that you mentioned?
Okay, there are websites that, on our NICHD website, we show you how you can access it, and you click on a link and it'll take you to the website where you can find out how to access it. So it's there. Usually most of these databases require that you're affiliated with either a university or research center or some other kind of research foundation, that you sign a data use agreement, because some of this data, even though it's de-identified, it needs to be used in a rigorous scientific way. And so that they do have those kinds of things that you do to get access to that data. But it's not too bad a process to do that. So if you go to the NICHD website, you should be able to find resources for researchers, and it's listed there. Otherwise, contact me, please, and I'll help you find it.
There's also a process now for scientific papers that are published for many journals, not all journals, but for many journals, to be made available freely to the public without having to have a subscription. after a certain period of time. You can go online and you can get those. It's through something called PubMed, which is a government database essentially. So you can access the reports that scientists publish about their findings.
So I have a question for the other two, both of you. A lot of information that a child gathers is visual input. So have you looked at how the exposure to different objects, different colors, and variety of objects actually impacts their development?
I didn't understand the last part. How objects, different colors, et cetera.
How exposure to different visual stimuli impacts development.
So I can't answer that directly, but there's a lot of work now that's being done, as Lisa said, on using, on looking at the development of attentional systems. If you think about it, what we pay attention to in this very complicated environment is going to determine, in fact, sort of what our next response is within a certain context, right? What are we looking at? What are we hearing? If you're in a complex environment, you have to filter certain things out that are not important. You have to tend to certain things that are going to be really important in defining what you're going to do next. And it turns out you can do those measures in infants, and you can sort of track them over time in terms of the kinds of things that seem to be most salient to them, the things that they pay most attention to. You might be shocked by this, but Elmo turns out to be a really salient object for infants. We've done some eye tracking in 1-month-olds, and it's really quite amazing. Elmo, I don't know what it is about Elmo, but Elmo is incredibly salient. But there are other cartoon characters that have no impact whatsoever. So the studies are more about trying to use different objects, colors, movement. What are infants paying attention to? How long they spend attending to something before they get distracted or attend to something else. I think those are the kind of developmental studies that are being done now. And it turns out that, from my perspective at least, I'm a little biased, I think that this is a really exciting area because you can do these things, tracking attention really early. It's wireless now. You don't have to attach an infant to all these wires. And we're going to gain a lot of insight in terms, because infants don't have language, right? We're going to gain a lot of insight in terms of what they're paying attention to and what they're not paying attention to. It's a very exciting time.